Thank you all. The breakthroughs in AI that we are here to celebrate today did not come for free. We had to get rid of a lot of dogma before we got here. You see, in the initial days when deep learning started to taking off, a lot of really smart people kept going as if nothing had happened. Now, I'm not claiming I'm one of those really smart people, but I was one of those that kept on to my old research for a while. You see, soon after my PhD, deep learning came and rendered much of what I have done up until then obsolete. That was, of course, a pretty tough blow. But when I looked at this technology, I was just so excited about what it could do that I just never looked back. And I think now organizations are at a similar inflection point where the breakthroughs in AI are starting to make stuff possible that wasn't possible before. But to really reap all these benefits, I think we really need to rethink how we're doing some things and start to reimagine what could be done. And I think we have all the ingredients to do that. Here's why. So, intelligence, or the cost of intelligence, is plummeting, driven by three factors. First, we have a universal architecture that can take any type of input modality, such as audio, text, video, images, even molecules. And this means that any improvements to this architecture from software and hardware developments will basically lift all of these domains at once. So we'll see improvements across all areas without any specific effort towards one of them. Second, we've embraced a bitter lesson, and that's related to the first one. We found that when we scale up the amount of data we pour into these models and the computation used to train them, results go up predictably. We have this scaling loss. This means, just to give you an example, the difference between GPT-2 and GPT-4 is kind of like a toddler to a university student. But the only thing we changed really was making the thing more efficient so that we could train it on larger and larger compute and more data. That's really the only difference. Third, we see that similar scaling laws now hold at test time. This means when you give the model a task, if you let it think for longer, use more computation as it goes, and use reasoning techniques, such as those created by using reinforcement learning and guided search, these models can now further improve just by using more computation. And of course, now that we have so much pressure on innovation, also with the globally, we'll see now that these architectures will be much more efficient really rapidly. Lastly, we have this thing called self-improvement or self-play, where we can train these models on their own output. This is now starting to kind of work. It's not really working fully yet, but it's kind of working. This is a bit contentious. Some think that we're going to hit a wall anytime soon. They've said that for many days now. But I think when you look at the technology and the kind of first principles reasoning about it, I'm convinced that we're far from hitting a wall. Now, this is, of course, extremely exciting for a scientist and a technologist, but the implications reach far beyond the technical circles. When I started, it was a small group of people working on this. No one really cared about what we were doing, but now it has implications all across society and organizations. So an organization is designed around our cognitive capabilities. Everything from the organizational structure, decision-making frameworks, everything is really tied to how we operate. And now we have these machines that can think a million thoughts at the same time and pick the best one. Machines that know the best practices and facts about almost any subject. Of course, this means that we need to reimagine things. If we want to have these machines in our organizations and operate at full efficiency, we might need to rethink how we do things. But sheer intelligence is not enough. Imagine a brain in a jar. A brain in a jar that doesn't have access to the outside world. That's how most of us have experienced AI until now. We have trained these models, we deploy them, we have a chat interface, we can talk to them. So that is kind of the link to the outside world. But they can't gather new knowledge, and they can't take action, or they couldn't until recently. But now we have this thing called agents, and as Lauren alluded to, agents is the buzzword of 2025. Agents can do problem solving more end-to-end on our behalf. But what exactly are agents? An agent is basically a loop orchestrated by a large language model. At each step, it will take an action based on all its available information. It will observe the outcome of this action and then judge what the next best action is, given its goal. To take a simple example to contrast this agent architecture compared to a simple assistant, say you want to write an investment memo, and you ask it to search your information and write the memo. Now, if it can only do one search and not look at the results, or only look at the results and then generate the answer, if the search results are not good, the answer will not be good. But an agent can look at the search results, it can judge the relevance, it can write new queries if they're not good enough, and it can continue like this until it has all the information it needs. Of course, this sounds simple, but when you connect these to your internal tools and processes, you get something that is much greater than the sum of their parts. For those of you who have coded, you know that spaghetti code is not a really good way of writing software. You have to write a lot of code to get anything done. If you instead use a modular approach, where you have kind of Lego pieces of code that you can combine in flexible ways, you get something that gives much more power with less code. We are approaching agents in the same way. So we have tools that can be composed in different ways by the agent, and we have agents that can be combined into systems of agents that can solve problems together. And these can communicate with each other in standardized interfaces, meaning you can basically build from a small set of Lego pieces all kinds of complicated architectures. So let's look at what this looks like in practice in Sana agents. So say I'm going to Stockholm. There's some interesting event here I've heard. I might want to also meet some customers here while I'm here. So I'm going to ask Sana to find my top 3 customers in the market in Stockholm. It's going to do research on them, prepare a brief, and then email with my available time slots to get scheduled. So let's see if this works. It's thinking at least, so that's good. Now it's going to look at basically search internal database, find customers. It's going to look up information on them. It's going to compose these nice little artifacts that contain the briefs. We can see as it's going, it's writing them as we speak. It contains the information basically harvested from our internal communications with them, our emails and documents on these customers. These are made-up customers, by the way. And I can then share these. We have a share button up here. I could share these with my colleagues. So it's like a document that was created for me. Now I can go down as well. I can go down here, and I can see this stack of emails that has been drafted for me. So let me review those and see if they look good. This looks good. This looks good. But I'm going to send this. So the emails have been sent, and I didn't really have to do anything except ask the agent to prepare this for me. But we can do more. We can also do things like writing code. So here I asked Sana to basically look at our pipeline targets for Q2 and the sales performance of the team. And I asked it to update the targets based on the recent performance. As you can see here, it made a plan to first check the structure of the deals data, check the conversion rates data, check targets data, and so on. It's writing code here to analyze this data. It calculates things and outputs these nice heat maps with the win rates across stage and business unit, weighted pipeline, and so on. I also get this as an artifact here. Now I could share this with my colleagues, or I could also create an app from this, which would be then updated as the underlying data updates, because I didn't copy-paste any files into here. The agent finds these files or data sources and can acquire it from my databases, and then I can have this link set up. But everything I did until now was basically me asking Sana to do stuff. I can also set up these tasks where things will happen on the background, because we can run these agents asynchronously as well. So here we have a few curated tasks. You can also create your own tasks. You can share them within the organization. You can learn from each other and so on. But say I have this prepared for my meeting set up. So before each meeting, it will look at my calendar. When there's a new meeting, it will look at the title, the participants, the agenda. It will search all the internal documents and so on that will be relevant and prepare me with a briefing. Let's see what it did. It's scheduled now. There's something happening today, apparently. Oh, it's the Sana AI Summit. So here we have the speakers and participants. We have this So here Sana decided to search the web also for each of these participants and give me inline references to what it found. We can see also that it gave me some instructions here to rehearse your keynote speech. I did reasonably well on that, I think. But I was also up a bit late last night. But so that's one example. I can also go to my home screen. And here I have another example where Sana has gone into my calendar or just tracked my calendar and saw that I have an upcoming trip to New York. It can go then and search and prepare things for me to get me ready for that. So these are just simple examples of agents. You can configure your own agents, you can set up your own triggers, you can connect them to your databases, your CRM systems, basically everything, because all of these are tools that are very flexibly and dynamically combined. And I think this is only the beginning. This is just like the baby steps of where we are heading with this technology. I think eventually everything we see on the screen will be basically generated by a neural network. A neural network that combines code, data, and design to build rich user interfaces for us that are tailored exactly to what we need to do and exactly what information that is relevant for us. But it's not only the user interface that might change. You see, one thing about these agents is that they're still bound by my permissions. So if I don't have access to something, the agent doesn't either have access to it. And this is good if you really care about security, which we do, but it also has limitations because this means that all the information in the organization that would be relevant to me is not available to me. And the problem is that a lot of these cases, the permissions I have are not based on what I should be able to see. Rather, they're based on what licenses did someone grant to me based on my role. And I think that has to change. I think we should use AI to have a much more flexible and dynamic permission model where the information available to me is based on what I need to get done, the sensitivity of the data, and not these kind of broad team license-based models. Yeah, as I said, agents are as people bounded by the same permission models. Now, we don't really know where this technology is going. I have ideas and visions, but I don't think I have all the answers, and none of us in here has all the answers. The only way to find out is to explore, learn, and share radically across the whole organization, across all of society.